Module 5, problem number 12. Do people walk faster in the airport when they are departing, getting on a plane, or do they walk faster when they are arriving, getting off a plane? A reputable researcher measured the walking speed of random travelers in 2 international airports. His findings are summarized in the table. Complete parts A through C below. Before I open the table, we're going to go ahead and do part A. It says, is this an observational study or a designed experiment, and why? Well, let's think about it this way. A designed experiment is typically there's some input from the researcher that can either help with the study or impact it. For example, looking at like 2 different prescriptions and comparing them. You're having a control group and an experiment group. That's a designed experiment. This is observational. Someone simply sat at an airport and watched people and timed them. There was no influence. There was no certain profile of people. There was no breakdown. It was just a completely observational study. So we are going to read the 2 options for observational, A or D. It says this is an observational study since the researcher did not influence the data, or D says influence the data. Well, again, the name implies observed, not influenced. So let's check A. Fantastic. Explain why it is reasonable to use Welch's t-test. This one we can just say, we know basically like our major checkoffs for requirements for these different tests is the sample's random, large, and independent. So we can do that. Do individuals walk at different speeds depending on whether they are departing or arriving at the alpha equals 0.01 level of significance? Let mu1 represent the mean speed of people departing and mu2 represent the mean speed of people arriving. So again, let's look at the different alternative. Again, the null hypothesis we know is always going to be mu1 equals mu2. The alternative, in this case, we're looking to decide, is it different or is it less than or greater than? In this case, they literally just said, are they different? So if they're different, we know that our alternative hypothesis is that mu1 does not equal mu2. Determine the p-value for this hypothesis test. So let's go ahead and look at our findings from this study. As you can see here, we have the departure people getting off the plane, arrival people getting, departure getting on a plane, or arriving getting off of a plane. We have their mean, standard deviation, and sample size. So those are all the numbers that we need to run our hypothesis test. So I've already opened up StatCrunch right here. So we remember this is an independent samples. These are not paired samples. It's not like we care if the same person got on or off the plane, if we're making sure to follow that person at their departure and their arrival. That's not this type of study. This one is an independent mean test. So we're going to go to stat, t-stats, to sample. Again, if we were here at paired, that would be the for matched pairs data. Here we have a to sample with summary. So we're going to type in our sample mean 255, standard deviation 49, and sample size 35. And then for our second sample, the arrivals, we have 273, 37, and 35. And as we talked about just a minute ago, our null and alternative are equal to and then does not equal. So here it's already automatically selected. We're going to click compute and we get our p-value of 0.088 when we round up. So 0.088 to round up. Good job. So now choose the correct conclusion. Again, we've talked about this before. If the p-value is less than alpha, then we reject the null hypothesis. However, when p-value is greater than or equal to alpha, we do not reject the null hypothesis. So in this case, we have our p-value right here is 0.088, which we know is greater than 0.01, which is our alpha. So we do not reject the null hypothesis. So we know right now that B and C are out automatically. Now, when we do not reject the null hypothesis, we know that we're saying that it's not necessarily true that the null hypothesis is accurate, or is true. However, we're saying there's not sufficient evidence to support the alternative. So here we see in A, it says there is sufficient evidence to support the alternative hypothesis. In D, it says do not reject the null hypothesis. There is not sufficient evidence at the alpha equals 0.01 level of significance to say that travelers walk at different speeds depending on whether they are arriving or departing. So here we say, oops, final check. Good job. All right, and just to kind of even think, sometimes some of these results, you can think about them intuitively. Some people might think they're in a rush to get on the airplane and get seated just to get onto their trip, and some people might be in a rush to get off and either get home or get to their destination. So I have a feeling that in both cases, people are usually just wanting to go as quickly as possible, and there is no difference. So a lot of times you can also just check your intuition to see if your results match up. So that's how you do number 12. If you have any questions, let me know.